my beautiful listeners, welcome again to class. It's your favorite channel, Jeff, 9 Mathematics class. And you all know, in this channel, we help students understand the basics of mathematics. Again, in our series, we have been doing videos on revision of matrices and determinants. In today's class, we are going to be looking at how we can solving problems on inverse of matrices. Inverse of matrices. And under this subject, we're going to be looking at inverse of 2 by 2 matrices and also the inverse of 3 by 3 matrices. These are what we are going to be looking at today. Alright, so if this is the first time joining us, you are welcome again to class. Sit back, relax, and follow the class as we begin. Now, we are going to be looking at the first example, which has to do with finding the inverse of a 2 by 2 matrix. Let's go. Example 1. Find the inverse of matrix A equal to 4, 3, 1, 2. All right, this is the first question for today. Find the inverse of the matrix A equal to 4, 3, 1, 2. How do you look for the inverse of, as you can see, this is a 2 by 2 matrix, because it has 2 rows and 2 columns. Now, how do you solve this solution? First of all, inverse is represented by a negative power 1. So the inverse of A can be written as A raised to the power of -1. That is the symbol for inverse, okay? Inverse of matrix A. Now, this is what you do when you are solving the inverse of a 2 by 2 matrix. It becomes 1 over determinants, follow me please, 1 over determinants, okay, into the matrix of, now you see these two elements here, they swap, these two elements swap, so here becomes 2 and here becomes 4. Now these two elements does not swap, but it becomes negative, you give them negative signs, so here becomes -3 and here becomes -1. Okay, so now without wasting time, look up, this is what I did again. 1 over determinants. You swap these two elements, alright, and then you give these signs, these elements negative sign. So let us assume that here was -3 originally. So it means if I'm giving this minus sign, it becomes positive, because minus times minus is what? Plus. Alright, let's begin. So now what are we going to look for class now? We are going to look for the determinant of this matrix. So let's go. Where determinant is equal to, right? Now let's look at the determinants now. 2 times 4 gives us 8 minus 1 times -3 gives us positive 3. And 8 minus 3 gives us what? 5. Meaning our determinant is 5. Alright. How did I get determinants? Normally 2 by 2 determinants. This times this minus this times this. Okay. Now that we've gotten our determinant to be 5, we will come back here. A inverse becomes 1 over determinant now is 5, so it becomes 1 over 5. And so we have 2 minus 3 minus 1 and 4. Now sometimes the answer can be in this form where the determinant is outside, and again it could be that they use the the fraction outside to multiply everything. So if we want to do that, it will look like something like this. A inverse becomes, now see, 1 times 2 gives us 2 over 5. 1 times -3 gives us -3 over 5. -1 times 1 gives us -1 over 5. And 4 times 1 gives us 4 over 5. Now, these two answers are the same. But the difference here is that here, the determinant is outside. But here, we use the fraction outside to multiply all the elements inside. So this becomes the inverse of this matrix A. It's as simple as that, alright? It's as simple as that. So the next part we're going to be looking at now is how we can solve problems on the inverse of 3 by 3 matrix. This is the part that we will be looking at, today. Very, very important. So you have to make sure you pay attention to all the steps we are going to be taking. Okay, let's go. Example 2. Find the inverse of, okay, 3, 1, 2, 2, 1, 0, 4, 1, 1. Alright, we should look for the inverse of this matrix. How do you solve for the inverse of a 3 by 3 matrix? Let us assume the matrix is matrix X or matrix P, or you can give it any value. So it means that if we're looking for the matrix of P here, if we are using P, it means that P inverse becomes, this is the formula you use, P adjoint over the determinant of P. This is the formula we're going to be using. P adjoint over the determinant of P. How do you get the adjoint of a matrix? It simply means the adjoint of a matrix is the transposition of the cofactor of that matrix. Remember we said, how do we solve for transposition? Our rows becomes the what? The column. So for us to get our adjoint, it means that after we have found the cofactor of this matrix P, we will not transpose the answer. That answer after transpositing becomes your what? Your P adjoint. But don't forget that what we're going to do now, we are also going to look for the determinant of P here. So in this question, we're also going to look for the determinant of this matrix, which is a 3 by 3 matrix. Well, there's going to be a lengthy one, but let us just see how we can work this out. Now, first of all, let us find the determinant of P. The determinant of P. Now, for us to get the determinant of P, remember I gave you two methods for solving the determinant of P. Either you pick this 1, 3, 1, 2, or you make these three columns becomes our what? 5 columns. Alright. So now, without wasting time, we're going to be having this. Let us assume we are using method 2 of our determinants that we spoke before. We're going to be having this. We're writing this question 3, 1, 2, 2, 1, 0, 4, 1, 1. So now what we're going to do now is that the first 2 columns here, we're going to rewrite it. So here becomes 3, 2, 4, and here becomes 1, 1, 1. So now let's work it out. Determinant of P now becomes multiplying diagonally 3, 3. 3 times 1 times 1 will give us 3, plus 1 times 0 times 4 will give us 0, plus 2 times 2 times 1 will give us 4, minus, now we start from our right to the left now. 1 times 2 times 1 gives us 2, plus 3 times 0 times 1 gives us 0, and 2 times 1 times 4 gives us 8. Okay, so now this is what we are going to get. Alright, it becomes determinant of P is equal to 3 plus 0 plus 4 gives us 7, minus 2 plus 0 plus 8 gives us 10. And 7 minus 10 will give us minus 3. So it means the determinant of this matrix P is minus 3. So now that we've gotten the determinant, what are we going to look for now? Let's go get the cofactor, which is after getting the cofactor, we'll now transpose it to get our what? Our P adjoint. So now, let's see. Don't forget we said before we can get cofactor, we have to first of all get our minus. So how do we get our minus? Bringing back the original questions, which says, okay, no, even without rewriting, let's just pick it out from here. Now, my first number here is 3, alright? So now, don't write this, don't write this. I'm going to be writing our words now. The 4 elements here, which are what? 1, 0, 1, 1. Okay? Now, next one now is what? 1. So, I'm not going to write this below and this beside. So, I'm going to be writing words now. 2, 0, 4, 1. Alright? Because of the space of the board, I have to manage it. And the last number now is 2. Alright? So, I'm not going to write it 0, 1. I'm not going to write it 3, 1. I'm going to write it 2, 1, 4, 1. 2, 1, 4, 1. Alright, so we don't need the numbers, alright? So let's do the next one now. 2. So I'm not going to write it this. I'm not going to be writing this. I'm going to write it 1, 2, 1, 1. Alright? Next one is 1. I'm not going to be writing this. I'm not going to be writing this. I'm going to be writing 3, 2, 4, 1, right? 3, 2, 4, 1. Let's see, the first one we looked at was this, okay? Yes, 1, 2, 1, 1. And so here becomes 3, 2, 4, 1. And lastly, here we have 0. So I'm not going to be writing this, I'm not going to be writing this. I'll be writing 3, 1, 4, 1. Okay? Because of the space of the board. So let's see here. Here, 4. I'm not going to write in here. I'm not going to write here. I'm going to write in 1, 2, 1, 0. So I have 1, 2, 1, 0. And then here, I'm not going to write in here. I'm not going to write in here. I have 3, 2, 2, 0. 3, 2, 2, 0. And then lastly, here. I will not be writing here. I will not be writing here. I'm writing 3, 1, 2, 1. 3, 1, 2, 1. Because of the space of the board. Now, don't forget that we are still solving. So now let's erase here out. Okay. Let us proceed. Now, 1 times 1, find our determinants now. 1 times 1 gives us 1. So here becomes 1 minus 1 times 0 gives us 0. So here becomes 2 times 1 gives us 2. Minus 4 times 0 gives us 0. Here becomes 2 times 1 gives us 2. Minus 4 times 1 gives us 4. Right. Now next. 1 times 1 gives us 1. Minus 1 times 2 gives us 2. 3 times 1 gives us 3. Minus 4 times 2 gives us 8. 3 times 1 gives us 3. Minus 4 times 1 gives us 4. Alright. Now the last one we have. 1 times 0 gives us 0. 1 times 2 gives us 2. 3 times 0 gives us 0. 2 times 2 gives us 4. And lastly, 3 times 1 gives us 3. 2 times 2, gives us 2. So let's go. 1 minus 0 gives us 1. 2 minus 0 gives us 2. 2 minus 4 gives us minus 2. 1 minus 2 gives us minus 1. 3 minus 8 gives us minus 5. 3 minus 4 gives us minus 1. 0 minus 2 gives us minus 2. 0 minus 4 gives us minus 4. And lastly, 3 minus 2 gives us 1. Class, don't forget. Don't forget. This is not our cofactor. How do you get cofactor? You now what? Assign the signs. So each of the what elements here. So let's assign the signs now. Here becomes minus. Here becomes plus, minus, plus. Here becomes minus, plus, minus. Here becomes plus, minus, plus. So let's go. Our cofactor becomes 1. Now here becomes minus 2. Here becomes plus times minus. Still remains minus 2. Here minus times minus now gives us plus. So here becomes a positive 1. Now plus times minus gives us still minus 5. Minus times minus here now gives us positive 1. Plus times minus still gives us a minus 2. Minus times minus gives us a positive 4. And here still remains a positive 1. And you there? Now, this becomes our cofactor. But don't forget we are looking for the adjoint, not the cofactor. And we said the transposition of the cofactor gives us our what? Our adjoint. Therefore, P adjoint becomes, our first row becomes our what? Column, which gives us 1 minus 2 minus 2. Second row becomes 1 minus 5, 1. Third row becomes minus 2, 4, 1. This becomes our what? Adjoint. Therefore class, therefore, the inverse of P, which says P adjoint over determinants of P, becomes, the P adjoint now is this matrix Our determinant of P, what's our determinant of P just now? Minus 3 or what? Minus 3. So here it becomes 1 over minus 3, because our determinant is minus 3, into the matrix of our adjoint matrix now is 1, 1 minus 2, minus 2 minus 5, 4, minus 2, 1, 1. Now, of course, you don't allow your denominator to carry a negative sign. So what do? Your minus sign divides the positive sign, which is at the numerator, to give us a minus sign. So therefore, our answer becomes what? Minus 1 over 3 into the matrix of 1, 1 minus 2, minus 2 minus 5, 4, minus 2, 1, and 1. This becomes what? Inverse of matrix. So class, you see, all of this has to do with steps. What was our first step? We solve for the determinant of P. And after this, we look for the minor. And after the minor, we look for the cofactor. And after the cofactor, we look for the transposition of the cofactor to get our adjunct. And then after this, we substituted all of this into the function. And then we got this answer right. So class, we have come to the end of today's teaching. I hope you've learned something new. Till we meet again in our next class, don't forget to subscribe to our channel. Don't forget to share our videos. Don't forget to keep learning, because learning is never an ending something. Till we meet again, bye for now.